Our lesson today is going to talk a little bit about a process that was developed by the mathematician and philosopher Eratosthenes. And then we're also going to talk about how to use algebraic expressions in when we're dealing with factors and multiples. For your warm-up, I would like for you to look up, you can Google this if you like, who Eratosthenes was, where is he from, what did he do, that was significant in the field of mathematics, or any other important information that you find. How long ago was he alive and did he work? Okay, things like that. Go ahead and pause the video and write that information in your spiral. Okay, hang on to that information and we will talk about that in class. Located on Canvas, there is a PDF copy of this grid of the numbers 1 to 100. It's just a 10 by 10 grid with the numbers. You could draw this in your spiral if you like, but if you would like to print off this page from Canvas, you can do that as well. And all I'm going to do is just walk you through a couple of steps for using the sieve of Eratosthenes. Okay, so in this exploration, we are going to mark out the number 1, okay? And so I'm gonna mark out the number 1 with red. I'm just gonna put an X on the number 1. So this is how we're going to start, okay? And then I'm going to circle the number 2. I'm gonna do it in blue, a different color. And I'm going to cross out all of the multiples of 2. And so that would be me crossing out 4, 6, 8, 10, and so forth. So I want you to pause and cross out all multiples of 2. Okay, so your grid should look a little something like this. All right, so now what we're going to do is go to the very next number that's not crossed off, and that would be 3. And I'm going to pick a different color here, and I'm going to circle 3, and now I'm going to mark out all of the multiples of 3. Well, 6 is already marked out, so I will do 9, 12 is already marked out, 15, and so forth. 18 is already marked out, 21, and we just keep going until we've marked out all of the multiples of 3 that aren't already crossed out. And your grid now looks a little bit like this. And we're going to keep going with this process, so I'm going to pick a new color here. And we're going to circle the next number that isn't crossed out and then mark out all multiples of that number that aren't already crossed out. So I want you to continue to do this on your own. So I'm going to circle 7 and then cross out all multiples of 7 that aren't already crossed out, and then keep going. And let's see if our grids match each other when we're all done. Now that we've gone all the way through the list, double check and make sure that your grid looks like mine. The colors don't need to line up, but all of the numbers that I have circled, you should also have circled, and all the numbers that I have X'd out, you should also have X'd out. Let's take a look at these. What do these numbers have in common? Go ahead and make a quick list of things that you notice about these numbers. How else do these numbers relate to patterns that we have? Maybe think back to when we did our rectangle activity. So once we've kind of gone through some of these numbers, you will see a pattern develop, and all of these circled numbers have the exact same name. Do you know what that name is? Write it down if you think that you know what these are called. You are right. All of the numbers that are circled are prime numbers. Being able to recognize our prime numbers will be extremely helpful. Now, we're going to transition to talking about using variables with factors and multiples. Consider this statement. R is a multiple of 6. Write an algebraic expression for R. Remember, an algebraic expression just has variables, letters, that are being multiplied by numerical values, numbers. Okay, if R is a multiple of 6, then that means that, let's first think of different things that R could be, if R is a multiple of 6. R could equal 6, because 6 times 1 is 6. R could equal 12, because 6 times 2 is 12. Right? And so I'm just multiplying things by 6 to find all of the multiples. 6 times 3 is 18, so R could be 18, and so forth. But let's say I don't know what I'm going to multiply 6 by. So I'm going to say 6 times n. That is still a multiple of 6, even though I don't know what it's going to be. And that could represent r. So if I'm going to write an algebraic expression for r, I could write something like 6 times n. And that would be a variable expression that represents every multiple of 6, even if I don't know the multiplier that I'm going to use to multiply it by. Now let's suppose that 8 is a factor of m. Write an algebraic expression for m. Well, if 8 is a factor of m, that means if I take m and divide it by 8, I'm going to get some sort of integer. So here would be my algebraic expression for m divided by 8. I have a couple more questions to ask you about this one, though. Is 4 also a factor of m? So could I say, if m divided by 8 works, does m divided by 4 leave me with an integer as well? Is m divisible by 4, or is 4 a factor of m? Well, let's think about this. Pretend like we take the fraction m, and we break it apart. And instead of writing m divided by 8, we're going to write m divided by 4 times 2. Because 4 is a factor of 8, and 4 times 2 is 8. I could separate this, and I could say m over 4 times 1 over 2. Is this indeed the same problem? It is, because when multiplying fractions, you multiply the top times the top, which is m times 1 is still m, and the bottom times bottom, 4 times 2 is still 8. And so I still have the exact same initial expression. It's the same value. If m is divisible by 8, it also has to be divisible by 4, because 4 is a factor of 8. Is m also divisible by 3? No, because 3 is not a factor of 8. What about by 16? Well, this is a really good question. So I start off with m over 8, and I get to a value of 16 here. Well, that means I needed to change the denominator. I had to multiply by 2. But remember, whenever you change the denominator of a fraction, you have to be fair. You have to multiply the numerator by that same value. So I wouldn't get m over 16. I would actually get 2m over 16. And so 16 would be a factor of 2m, but not m. All right, let's take a look at our last example here. If 5 is a factor of 15, and 15 is a factor of 45, is 5 also a factor of 45? I want you to pause the video and see if you can figure this one out. Another way to ask this question is, if 15 divided by 5 is divisible, that gives me an integer, 3. And 45 divided by 15 gives me an integer. It also happens to be 3. Can I divide 45 by 5 and get an integer? Is 45 divisible by 5? Well, it actually ends up that the answer to this is yes. This will happen every single time. Because 5 is a factor of 15, meaning that I can break 15 down into 3 times 5. And if I leave it as 3 times 5, it will definitely be, and is a factor of 45, then 5 definitely is a factor of 45 as well, because 5 is in the 15, that is in the 45. And so all of these things kind of relate to each other. This one deals with a property called the transitive property. Okay, write that information down, and we will talk about this more in class, and I'll answer all of your questions. Have a good evening.